decision tree, right? Decision tree is the one of the best and is the best machine learning algorithm. And basically, when you talk about the decision tree, uh, we understand what is the decision tree in depth, but before that, decision trees follow both the problems. They solve the classification problem, as well as regression problem. Right? Solve both the problem. In this series, we learn all of this concept of a decision tree, how to use in a classification, how to use in regression, right? All steps one by one. So first, before that, what is a decision tree and why this called trees, right? Because that's a word that is used are in the data set. It's a tree. How they make a decision on the basis of trees that we will understand on the particular video. So first, basically understand when we create that algorithm create a tree-like structure, right? Tree-like structure. How they create a tree-like structure? Understanding the example of a if-elif statement, right? You know about a if-elif statement. That's a very useful concept, and they tweak when that algorithm make a tree, so they can make it tricks just like a if-elif statement, right? Understand how they make it trees first. So let's start with the we have a statement example, right? And we have a statement if statement we are using. So we have a age is equal to 14 and some writing down some if statement, right? So if the age is uh, great age is less than equal to 15, simply print simply print person in school, right? A person in school. Similarly, another example we get it. Uh, it is a if statement. If the age is age is basically in that case age is less than equal to 15 and age is less than equal to 21. They simply print a person in a college, right? A person in a college. And last is the else statement. Is simply writing else print the person is a pass. The person is pass passed out of the college. So that is the if statement, right? In simple concept, when we created tree-like structure for your model or using a distant tree, that simple case simply create just like that. In that case, let's age is less than equal to 15. In that particular case, we created two types of model, right? One, let's start with the yes, and this is no, right? We create two structure, right? That's one application is complete. If the student are if the student are age is equal to 15 or less than 15, right? This means they are in less than 15. It means the person are in school, right? The person in a school. The person in a school. Okay. And if what happening if the person is greater than 15. So in that particular is no condition, and we create a one more block. Basically, we create a one more tree-like structure. In that particular case, we create a simple. The age is in the second statement are common, right? So in that case, age is greater than 15 or less than 21. Okay. So in that case, yes and no. Right. So that is the creation that we are creating. And if yes, either in between that particular case, the person is on college, right? But if says the no, in that particular case, we create a one more trees-like structure, and they will be continuously further, and something like that, and many more times. So that type of creating simple created in decision tree, using basically just like a if statement, right? In a different structure and different differentiate that. So that's I hope you understand how to create tree-like structure and why. Uh, we get one more example that that will help you more to understand that concept. So let's start with that's the uh, example is a weather, temperature, humidity, and windy. And this output is basically it's a binary output, right? Uh, binary out binary output. In that binary output, simply that is a yes or no. When the weather is shiny, so you play tennis or not. Temperature hot, you play tennis or not. Humidity is if low, normal, so you play tennis or not, it's something like that. Okay, so that is a type that we have an understanding the concept of a decision tree. So first we are understanding with the let's we are getting with going with the weather. Okay, and one more thing, when you learn, well, that's in that particular case we have four features. Okay, one, two, three, and four feature. So which feature is selected for that splitting or creating decision tree? That also the next video and understand that concept as well, right? But first, we are splitting the weather. Okay. So in that particular place, that we have a one, two, three, five, six, seven, eight, nine, 10, 11, 12, 15. We have 15, yes, yes, basically yes and no. This simply divider weather. Okay. Okay. So we are creating a tree like a structure first. So we have a tree and that tree is a weather, right? We simply split that. And then in that case, we have how much yes and no. So one, two, that's three, four, five. Basically, this we have 10 yes and 5 no. Okay. So we when splitting data, so in that we splitting data, we have in a weather, sunny, one, overcast, and rain. So three type of uh, categories feature in a weather. Okay. So we divided in three. That is the one. That is the sunny. Second one is the out overcast, overcast, and third one is a rain. Right? There is a three type of sunny, overcast, and rain. So and we simply split one more split in how many yes and no are distributed. We will understand it. First, when is sunny, so sunny weather. So in that particular case, we have two nodes, okay, and then that is the yes, one yes, three nodes, and okay, and in this exam, we simply have a 2 years and three nodes, right? When we see about overcast, so in overcast is simply 1 year, okay, that is second year, and it's the 4 years, okay, 4 years and zero no. And rainy season we simply split that. That in rainy season we have a 4 year and three nodes. Okay. So that's we have a split in a different concept. Different concept of different segments. Okay. So when we learn about that concept, so we simply divided that thing, and we when we see that is split. So this is a pure split, right? This is how you say this is a pure split. That's impure split, impure split. That's also impure split. Why? How do how we decided that is a impure split or a pure split? So basically, this P, and this concept, this context will simply say that this is a leaf node. Leaf node. What is a leaf node? Basically leaf node is a final node that we create in the tree structure. Okay, that we have creation something like that tree-like structure, and multi times we creating a tree-like structure, right? So there's a final node. Meaning, there's a when we clear the pure split and last node that called a leaf node, and leaf node are creating many more times and much many more times. Okay. How first of all, understand how we decided that uh, which speed are pure, or how to take it. Basically, when we learn about that concept, so we will understand how to split and which one is a pure split or not. But problem is when you learn about the concept, just like when you train a model, or when you train a model, or mathematically instruction are came here. In that situation, you can't define, or you can't decide it's a pure split or not. Okay, so for that reason, for checking the purity, okay, uh, for checking a purity, we simply apply two techniques. Okay, we simply apply two techniques. So one is the entropy, entropy, and second technique is the Gini index, Gini index, Gini index or Gini impurity. That is for checking, or checking purity of a split. We can use that entropy and Gini impurity, right? Similarly, you know, similarly we have that three four features. There is weather, temperature, weather, temperature, humidity, and wind. So how we decided, how we decided which feature we selected. For that, we have one more thing is the uh, okay. That's the second one is the which feature we selected. How we decided that. So for that, we have a simple one more thing is that is an information gain, right? Information gain. Using the information gain, we select the feature, and for checking the purity, we use the entropy and Gini impurity, right? And that we will see all the concept in next video, understanding the